Hello everyone, welcome to Cookroid, and my name is Saurabh Kukreja. In today's challenge, we will be working with binary search trees and we'll find out the height of a binary search tree. To begin with, I'll quickly explain what a binary search tree is and then we'll go from there. So, this shows an example of binary search tree, which means that all of the nodes, the first property of binary tree is all of binary search tree is all of the nodes will have either 0, 1 or 2 children. That means 3 has 2 children, 2 and 5. 2 has only one child, which is 1, and 1 has no child. So it will have 0, 1 or 2 child. The second property is that the left element should always be less than the root element, than the parent element, and the right element will always be greater than the parent element. So with these property, we call it a binary search tree. And to find out the find out the uh, height of a binary search tree, what we will do is we will loop through all the nodes and we'll keep on adding as we go on to the next node, and we'll do on both the sides, right as well as left. And for this also we will go left as well as right, and then whatever is the highest node, highest longest path from root, which is 3, to the leaf, which is 7, that is considered height of the node. So to begin with, what I'll do is I'll take two heights. One is, I'll say left height. I'll initialize it with 0, and then second I'll say right height. I'll again initialize it with 0, and even before that I'll just say if my root is null, I'll simply return 0. That means like no root, the height will be null, height will be 0. Right now, if my root is not null, what I'll check is if root dot left is not equal to null, that means there is a left child available of this parent. So I'll say left height, we'll use recursion in this, is equals to, again we'll call get height, and this time what I'll pass in is root dot left, and then I'll say plus 1 because we have already traversed one path. This means when I'm on node 3, I'll say whether the left child is available or not. I'll see yes, 2 is available. I'll go and then I'll calculate the height from 2, and because I've already come from 3 to 2, that means I'm adding 1. Similarly, I'll check again if root dot right is not null, and if that's the case, then I'll say r height equals to get height root dot right plus 1. And then at the end, whenever all of I have both left height and right height, I'll simply check whether my left height is greater than right height. If that's the case, I'll return left height, else I'll return right height. That's it. This should work fine. Let's try to run it. Yep, that sounds good. Let's just submit it and see if all the test cases are working fine. So yeah, that's basically about binary search tree. We keep iterating through our left childs, and then we keep iterating through our right childs, and then whoever has the higher depth, we just say that is the height of the tree. Thank you so much for tuning in. Let me know if you'd like me to solve any specific problem, or if you have any questions or comment and finding the height of this tree. I'll be happy to answer that. Thank you so much, guys. Stay tuned.